Today we're going to be talking about RAM, otherwise known as computer memory. How does your computer remember stuff when the power's on and you're typing stuff onto your computer screen? We're going to talk about the different types of RAM, how it's packaged, and then also the newer types of RAM that you might be able to find in the stores today. So what does RAM stand for? Just like a lot of things when it comes to computers, there's acronyms. RAM is an acronym, stands for Random Access Memory. Well, what does that mean? Let's pull this acronym apart and take a look to see what the three words mean. Well, first there's the word random. This means that you can read memory in whichever order that you want. Imagine, as an analogy, say you have an old videotape and you want to watch the last scene in the movie, but unfortunately the tape has been rewound all the way to the beginning. So for you to watch that last scene, you have to fast forward the video until you get to that last scene. Now that type of access to information is called sequential access. With memory chips, you don't have to fast forward or rewind to get to the data. Now it used to be computer memory before they had these chips was stored on actual tape. If you remember from like old movies trying to show the old computers, you see these big tape drives kind of spinning in the background. That's basically the memory for the computer. If you needed to get information from the end of the tape and the tape was all the way wound to the beginning, you'd have to fast forward and wait for the tape to get to that location for you to be able to get to that data. With modern computer memory, you don't have to do that anymore. Nowadays, if you wanted to see the last scene in a movie and you had the DVD or the Blu-ray disc of that movie, you could just go to the table of contents or the main menu and say, okay, I want to see the last scene, and boom, you're there. You don't have to, quote, rewind the DVD or fast forward the DVD to get to that location. So you can think of a DVD as being random access, just like computer memory. Now, recognize that RAM is only for temporary storage of information. If the power goes off while you're typing, like say into a Word document, you're going to lose all the contents there and you're going to have to probably redo your work. I'm sure a lot of us have experienced that, where you've worked on something you haven't saved in a while and all of a sudden the power goes off or something bad happens, the computer program shuts down unexpectedly, and unfortunately the stuff in RAM never got saved to the disk, so now you got to redo the work. RAM is also known as primary storage. Without power though, primary storage doesn't work very well. You need to have power to have the computer remember anything. So where's this information stored? Well, if you may remember by looking at a motherboard, there's some slots in there for RAM chips or memory chips. Basically what people call these things are sticks of memory. Yeah, I guess memory sticks is the best way to say it. And on these sticks there are millions of transistors and capacitors. Each set of transistor capacitor represents a single bit of memory. So you can store 1 or you can store 0. And remember, everything in a computer is either a 0 or 1 because computers are binary machines. Now, how is RAM packaged or placed on a board so that you can actually put that inside your computer? Well, the current most common form of RAM packaging is called DIMM, or a dual inline memory module. It looks basically like a really small expansion card, but it has lots of contacts on it. If you look at the number of contacts, there are contacts on each side of the card, and they're connected to the memory chips. And DIMMs have been around for a long time, starting with Pentium machines or later. DIMMs have typically 168 pins. When I say pins, I really mean contacts. And again, there's 84 on one side and 84 on the other. And today's memory is usually installed 2 sticks at a time in order to maximize the speed of the memory. Some people claim that's not the case, but for dual inline memory modules running at double data rate, it's better to store or install memory 2 sticks at a time. Now these DIMM cards or memory sticks are inserted into the memory expansion slots located on the motherboard, and they're also known as the memory banks. Computers that I've seen lately usually have 4 of these, Typically you populate 2 of them when you get the computer, and then if you want to upgrade a little bit later with a little bit more memory, buy 2 more sticks and insert those into the next couple slots, and then you've hopefully doubled your memory capacity on your computer. Now these slots are much smaller than the ones you see for the adapter cards, and they have little clips on the sides. Make sure to open those clips before you try to put new memory in. When you press the memory sticks in, press down straight from the top using your thumbs at both ends, and that should snap it into place. Make sure not to plug them in backwards. There's a little notch that you have to get in the right way, and you shouldn't be able to install the memory stick backwards, but I've seen people force it in there, and then when they turn the machine on, the memory stick melts. So don't be one of those type of people. Make sure you have the memory oriented in the correct direction. Press straight down. You'll hear a click on either side. You know it's installed and the clips are in place. Now you're ready to use that memory. Now we've talked about packaging, but now let's talk about the actual technologies that are used to create this memory. Now there's a special type of memory called SRAM. This stands for static RAM. It's another type of transistor-based memory, and it's usually used for cache memory, and this is memory that's used inside the processor. So it's not memory you're going to go out and buy. This is memory that is housed inside the processor packaging. It used to be external to the processor, but nowadays with the most current processors, there's 2, even 3 levels of cache memory, and all of these use static RAM to store that information. The kind of memory you're going to install in your machine is called dynamic RAM, or DRAM, and this is what we use primarily for main memory. When you put these sticks in the computer, if you're a programmer type, when you create a variable or an array, this is where the information gets stored on these chips. These are what we call primary storage, as opposed to secondary storage. Secondary storage is things like hard drives and flash drives and things like that. Now, if you were to compare dynamic RAM with static RAM, here are the main differences. Where dynamic RAM needs constant refreshing to remember its zeros and ones, SRAM doesn't require that. DRAM is slower than SRAM, but it's a lot cheaper to manufacture, where SRAM is much faster, but it's a lot more expensive. So there's a trade-off there. On DRAM, each location or each byte in memory is given a specific address, usually represented in hexadecimal. But there are no addresses in static RAM. And of course, now all static RAM is housed inside the CPU, or the central processing unit. Now, a newer type of RAM is called SDRAM, or synchronous dynamic RAM. And it runs at the same speed as the system bus. I'm assuming this is the front side bus. Newer types of RAM than that are called double data rate SDRAM, and so they call it DDR SDRAM. But even this is kind of old school. This used to be the fastest RAM out there, but as with everything having to do with technology, things change, and change rapidly. So now you can see DDR2, even DDR3, which is the type of RAM we use in the machines that we're using in our classroom. I have even heard tell of a DDR4 RAM being out there and available right now. Now, it used to be that RAM was measured in nanoseconds. Now, a nanosecond is a billionth of a second, which is really, really fast. If you said you had 10 nanosecond RAM, that's going to be faster than 60 nanoseconds, even though 60 is greater than 10. The smaller the number, the better. If we look at the speed, or another way you can look at it is the time to recharge a bit, to keep it 0 or 1 in place. In old RAM, that was 60 to 70 nanoseconds. That's really old RAM. In newer RAM, if you had 100 megahertz RAM, or it'd take about 10 nanoseconds to recharge a bit, at 133 megahertz, it would take about 6 nanoseconds. Even at these seemingly fast speeds, those are really, really slow compared to today's RAM. If you look at the newest RAM out there, we're going faster than 1 nanosecond. The newest RAM, at least when this slide was created, was running around 1600 megahertz to recharge a bit, or 1.6 gigahertz approximately. That's really fast. And so they kind of gave up on the whole nanosecond idea. That was just too long of a time, if you can imagine it. Imagine that. So now when you go out and buy RAM, usually all they mention is the time to recharge that bit. It's usually in megahertz. I'm not sure why. They don't go up to gigahertz. They just keep it in megahertz for some reason. Interesting. Now I'm going to be buying RAM probably tomorrow, and you really don't want to mix different RAM speeds on your motherboard, because what your motherboard is going to do is going to say, okay, I've got this slower RAM and I have this faster RAM. I'm going to dumb down the machine so that it goes as slow as the slowest RAM plugged into the motherboard. So even though you buy really fast RAM and you put it in with RAM that's slow, it's going to run all the chips slow, which isn't the best use of your money. So if you really want to speed up your machine, I would take the old RAM out and put in new faster RAM, and then you might be able to get some performance improvement from your machine. But adding fast RAM to a bunch of slow RAM is just going to, it'll give you more RAM, but it won't give you faster RAM or faster access to the RAM. That's pretty much it on RAM. And again, just to summarize, RAM is what your computer uses to temporarily store information, and then when you're done editing the document and you're ready to save it, you can save it to the hard disk. Thanks for listening to this video. I hope it's been helpful and informative.